Okay, so hello everyone. We are Team Square and we are a team of five. And my name is Anshu Roy. I'm an undergraduate at NIT Hamirpur. And today I'll be walking you all through the overall project RegMind. And I'll be explaining you all the solution and the architecture of our project. So let's begin. Okay, so what is the solution and what RegMind actually does? So instead of treating the compliance as a manual workflow, we are building an autonomous multi-agentic system. So what a platform actually does is that it reads the new regulatory documents, understands them, and then converts them into engineering tasks, tracks the implementation, and verifies the technical evidence. And it even updates the existing work whenever there is a new amendment is released. Okay, so let's understand the system overview, how we are actually using agents to simplify our tasks and solve this particular problem. Okay, so our architecture consists of three layers. So our first layer is the sorting layer. So everything begins when an SCBI circular is uploaded into our platform. The first thing our platform asks is that does this regulation even apply to your organization? This is because not every circular is relevant to every financial institution. So a first agent compares the uploaded document with the organization's profile. If the regulation doesn't apply, it simply ignores that particular document. But if it's applicable, then we move to the next step. It extracts the text from the PDF, and then our second AI agent comes into act and it classifies the document into a master circular or an amendment circular because both act differently and we have different flows for both of them. So if it's a master circular, we built a compliance baseline. What is it? So instead of treating the document as one large file, we are splitting it into individual clauses because a master circular consists of many clauses. Each clause becomes an independent requirement. Also because each of these clauses may need different teams and implementations. So what happens next is that our domain trained language models comes into act and it reads every clause individually. It tries to actually understand the intent behind the regulation. For every particular clause, we are creating a structured obligation object, which will be stored in the database. This obligation object contains everything. For example, it has its own ID, then the section reference, it is referring to the original legal text, then the timestamps and the other metadata. I mean, everything about this particular clause will be stored in the database to maintain an audit and many other things that we'll discuss further. So this simply becomes the permanent record that the rest of the system will be using. So these clauses further needs to be categorized into two more types, which are actionable and non-actionable. Actionable are the ones that needs to be actually implemented by the IT team into their code base, and the non-actionables are simply kind of an information that needs to be kept record of in that organization. So the next layer is the action generation layer, and this is the main layer which is actually responsible for adding those tasks to the checklist. So after identifying an action, we then need to check that when it needs to be executed. This is simply because not every compliance requirement has the same urgency. Some might need immediate implementation because the SCBI has given a strict deadline, or some are recurring activities, for example, like quarterly validations or periodic reporting. And some might even be conditional, like if this happens, then only implement this part of code or something like that. So before creating any engineering task, our scheduling agent automatically assigns every obligation into one of these categories. Once this is done, our action generation agent takes over and it does the main thing. Okay, so what it does? So instead of giving the developers a paragraph full of legal terminologies, it translates that requirement into something engineers immediately understand. So here, every obligation becomes a technical task. It also generates an evidence checklist. This is very important because compliance isn't only about implementation, also about proving whether the implementation has actually happened or not in that organization. So here, everyone in the IT team here knows exactly what needs to be implemented and exactly what evidence will later prove the compliance. The next layer is the continuous state machine. And this is a very complex problem we have thought of and can be solved whenever an amendment is released. And we know that amendment consists of clauses on top of the previous master clauses. So it's like an update. So whenever there are updates in this amendment circulars, we need to care about how were they previously stored in the database and how will they be stored now after the amendment has released. So we need to compare these things and then take our next actions. So let me explain you this. So usually what happens is that when an amendment arrives, someone from the compliance team has to manually compare it with the previous regulations. Then they try to figure out which particular engineering task needs an update. Sometimes developers even continue working on few outdated requirements. So a platform solves this differently. So whenever an amendment is uploaded, the system first analyzes every updated clause. It simply asks a simple question. Is this particular amendment introducing a completely new requirement, or is it modifying something that already exists in the database? If it's a new requirement, we simply create a new obligation. But if it's modifying an existing rule, our state machine becomes active. So here, instead of creating duplicate tasks, it checks the live status of the original engineering task. Okay, so now let's understand the automated verification part by the IT department side. Okay, so once they finish implementing a task, the final step begins. The developer uploads supporting evidence related to that implementation. This could be anything like source code, configuration files, or anything related as a proof. After them uploading these docs, a verification agent immediately compares that evidences against the original regulatory obligations. And if everything satisfies the regulatory requirement, the task is marked compliant and the dashboard updates automatically. But what happens if something is missing? Traditional systems usually reject the submission and send it back, but that creates another cycle of emails and meetings. So we wanted to eliminate that thing. So instead of simply rejecting the evidence, RegMind.ai explains what's exactly wrong in that particular evidence. So this way, the engineer immediately knows that what needs to be fixed. This significantly reduces the review cycles and allows the compliance and the engineering teams to work together much more efficiently. Also, in this entire journey from document upload to the final verification, every decision is timestamped and securely recorded. And this is how the whole complete audit trail is maintained. Okay, so this was the overall flow and the architecture of a project. And this video was made for the idea submission phase. And thank you for your time.